So let's suppose you were actually given a problem like 1 over x squared minus 5x plus 6 to integrate. If it had been two separate fractions, we know that we could do it pretty easily, but as one fraction it poses a problem because U substitution doesn't work. So what we're going to do is break this up into partial fractions. So I'm going to divide it up into two fractions where I have a numerator in one of my factors as the denominator plus a different numerator in one of the factors, and I have to figure out what those are. So step one is actually to factor the denominator, to figure out how I'm going to split this fraction up. So I know that x squared minus 5x plus 6 is really the same thing as an x minus 2 and an x minus 3. So I'm going to say that this is a over x minus 2, and I have no idea what a is, and then b over x minus 3. And again, I have no idea what b is, but I'm going to add these two up, and I'm going to have two partial fractions, and these are going to be easier to integrate than looking at something like that. So the question is, how in the world do I figure out what these are? Well, remember that your a gets multiplied by x minus 3 when you actually add the fractions, and the b gets multiplied by x minus 2. And what that actually has to equal is your numerator, because your denominator is your x squared minus 5x plus 6, so this will equal my 1. And that sets up a nice little system of equations. Well, it's one equation, and it looks like we have a whole bunch of variables, but it's pretty easy to solve. So we're going to do something called Heaviside's method, and it's named after the English mathematician Oliver Heaviside. And what you're going to do is pick some very convenient values of x, because this equation has to work for any value of x, so we're going to pick nice ones. So I'm going to pick a value of x that will make this term go to 0, and a value of x that makes this term go to 0. So the first value of x I'm going to pick is x equals 3, because I know 3 minus 3 is 0. So I'm going to take this x minus 3 and plug it in, and that's going to let me solve for one of either a or b. The second x value I'm going to pick to plug in is x equals 2, because that will make this term go to 0. So look at your equations that you have now. When x equals 3, 3 minus 3 is 0, 0 times a is 0, 3 minus 2 is 1 over here, so I have b times 1, so just b equals 1. And I know that this b is really a 1. So if I plug in x equals 2, then I have a, and then 2 minus 3 is a negative 1. 2 minus 2 is 0 times b is 0 equals 1. So a negative 1 times a equals 1, that means that a equals negative 1. And I'm down to actually two partial fractions, both of which are easy to integrate. They are U substitution, and they do involve logarithms, but for both of them my du's are 1. So for this problem, we're going to go through the whole process. So step one is to factor, actually step one is to check and see if U substitution works. So U equals x squared plus 3x minus 10. My du would be a 2x plus 3. That is not going to match with the 4x plus 41 dx. So I know it's not U substitution. Step two, factor the denominator. So factors of 10 that when I add up I get a positive 3 would be a plus 5 and a minus 2. So I'm going to split this up into two partial fractions. I know that one of them is going to have x plus 5 in the denominator, and the other is going to have x minus 2 in the denominator. So now I'm going to write out what my numerator would be. So it's a times x minus 2 plus b times x plus 5, and I know that that has to equal 4x plus 41. The two values I'm going to pick for x are x equals 2 to make this term 0, and x equals negative 5 to make this term 0. So when x equals 2, this cancels out. 2 plus 5 is 7. So I have 7b equals, and I plug the 2 in here as well. So 4 times 2 is 8, plus 41 is 49. Solving for b, I have b equals 7. So I'm going to put a 7 right here. x is -5, plugged in, -5 minus 2 is -7, so I have -7a. This term goes to 0, equals 4 times -5 is a -20, plus 41 is 21, and that means my a equals -3. So I'm going to integrate a -3 over x plus 5 plus a 7 over x minus 2 with respect to x. And if you look at these, both of them happen to have a u that gives a u prime of just 1. So this is logarithmic integration again. It's a 1 over u du times -3 and a 1 over u du times 7. So my answer will be -3 times the natural log, the absolute value of x plus 5, plus 7 times the natural log, the absolute value of x minus 2, plus c. And that is how you will integrate that fraction. So to do this again, step 1 is to factor. I have x plus 1 times x plus 2. Then I write out my partial fractions, a over x plus 1 plus b over x plus 2. Then I'm going to write out what my numerator would be. So a times x plus 2 plus b times x plus 1 equals my actual numerator of 6x. I pick my two values to plug in. So I'm going to choose x equals -2 to make this term 0, and that means this is 0, -2 plus 1 is a -1, so b equals 6 times -2 is -12, so I know b equals 12. The next value I'm going to pick for x will make this term 0, so x equals -1. -1 plus 2 is 1, so just a. This goes away, equals -6. So up here I'm going to take away my a and I'm going to put a -6. Again, this works out nicely, and you do need to be careful and check, because you can factor. If I'd had a coefficient in front of my x squared, I could get a u prime that's not 1, and this gets a little bit harder, but not much. But I'm going to look at this. For both of these problems, my u's are going to give me a du of 1 dx. So when I integrate, this will equal -6 times the natural log, the absolute value of x plus 1, plus 12 times the natural log, the absolute value of x plus 2, plus c. One more problem. Going through the same steps, I look at this, u substitution does not work. I have a 2x plus 3. That can't match a 2x plus 21. So I factor. And factors of, this should be a -10. I was like, that wasn't working. So I'm going to say it's x plus 5 times an x minus 2. So I will have a over x plus 5 plus b over x minus 2. And I'm going to use Heaviside method to figure out what a and b are. So a times x minus 2 plus b times x plus 5 equals my actual numerator of 2x plus 21. First value of x I'm going to pick is 2 to make this term equal to 0. Then 2 plus 5 is 7. So 7b equals 2 times 2 is 4 plus 21 is 25. So b equals 25/7. The next value will be a value of x that makes the second term 0, so x equals -5. -5 minus 2 is -7. This term goes to 0, equals 2 times -5 is -10 plus 21 is 11. So from this I know a equals -11/7. Both of these have a du of 1 dx, so it's very easy. It is a -11/7. natural log absolute value of x plus 5 plus 25 sevenths natural log absolute value of x minus 2 plus c. And that is the very, very basic form of doing integration by partial fractions.